Okay, so we're going to weigh out some sodium metal in this example. This is sodium. Sodium is an alkali metal, as most of you remember, hopefully from first semester. And I zeroed out the balance. We got a little wind during this demo. So I'm going to put some sodium in there. We're going to add a little bit. Um, I have the lost a piece there. I have the electronic balance set to pounds right now, so I'm going to switch it here in the video. And we're going to switch it up to grams. And it's going to give us about 5 grams of sodium that you're going to see in there. So you can see that on the balance. It's hovering around 4 to 5. Not a real good electronic balance. It's a food scale for our kitchen, but it works. Okay, so we're about 5 grams. Okay, so we're going to show you how to set up this problem using a Google Jamboard here. We've got sodium plus water, and this is what we're going to be doing. We're going to be reacting these, and we get sodium hydroxide, which is NaOH, and we also get H2 gas. So remember you put a metal in water, an alkali metal, you're going to get something with hydroxide, which is OH, and you're going to get H2 gas. And the balanced equation is 2, 2, 2, 1. So I start off with my 5 grams of sodium. And the question is, how many liters of hydrogen gas are we going to get at STP? Okay, so in this, we do our setup. Remember, the 23 grams is coming from the periodic table. Got our moles. Second step is to use the equation. And in the equation, it's 2 moles of sodium for every 1 mole of hydrogen gas. That last step we're going to put in there is to get it into liters. And remember, at STP, 1 mole of any gas takes up a volume of 22.4 liters. So we're going to put that into the last step. And then, I'm going to use my trusty calculator and multiply 5 times 1 times 1 times 22.4, divide by 23, divide by 2, divide by 1. Again, leave the ones out in a calculator, and I'll get my answer of liters of H2 gas. It's going to come out to about 2.43 liters of hydrogen gas, as long as we're at STP, 1 atmosphere, and 0 degrees Celsius. Now, it's a little warmer. So here's the demo. Okay, well, it's a little windy, so we're gonna try to. Oh my gosh, it's really windy. All right, I'm gonna go ahead and put it in. There you go. There's another piece. Let me do another one.
Yeah.
It's a little smaller, but it worked.
Whoa.
Okay, cool. All right, you can hit stop. Okay, so you notice it was really windy today when I was doing that demo with my son out there. When I put in the initial amount of the sodium, I was trying to get all of it in there at the same time, and some of it got stuck in the cup, and I didn't notice it until I'd already started it. So between those two reactions, we should be able to get about 2.43 liters of hydrogen gas. Now, in that reaction, it's single replacement. You're getting the sodium and the hydrogen to switch places. And that hydrogen gas that's generated gets hot because the metal gets hot when it's reacting with the water. And if you get enough of the activation energy going that we've talked about, it will light. And that's where the explosion portion's coming from. Now, this is not one you want to try at home. This is it's not safe stuff to mess around with. But I've been doing this for about 16 years. You notice the smoke that came off of that, or the cloud of gas that came off of that, was a lot of water vapor and a little bit of sodium hydroxide coming out of that. And we wanted to make sure we were doing it so that the wind was at our back, so it would blow the stuff away from us and not into our faces. So we didn't use a huge amount on this one, but you can see the reaction. You can see how we can use stoichiometry to figure out how many liters of gas we're getting out of that. And if we could trap the gas, then we could actually see how close we are and do some percent yield stuff and see if we got the yield. We did not get the 2.43 liters, I'm sure, on this one, but I don't know the percent yield for this reaction, an average of it. So But anyway, just a little demo for you guys. Sorry we couldn't do it live, but we had some issues there, but we got it working here. So, okay.